Hello there, and welcome to today's lesson where we are going to write formulas for ionic compounds that contain polyatomic ions. All right, before we get into how to write formulas for these compounds, let us look at the difference between monatomic ions and polyatomic ions. As you can see on the screen, monatomic ions are made of one element. All right, you'll have sodium, strontium, chloride, and oxide here. So it's all just one element that has either lost or gained electrons. Polyatomic ions, on the other hand, are made up of multiple excuse me, multiple elements, two or more elements. And so you have a bond, and in this case, it is a covalent bond that occurred between the nitrogen and the hydrogen. But because of differences with electronegativity and with how many hydrogens and nitrogen are bonded together, the overall charge for this uh, species, if you will, is positive, or it could be negative, as you can see with the case of sulfate and carbonate. So in essence, a polyatomic ion, anything that has a polyatomic ion bonded in it, is both ionic and covalent. So that's pretty neat. Um, Writing the formulas, we're still going to balance the charges. So making sure that our positive ions equal our negative ions, um, that's still going to happen even with polyatomic ions being in this case. All right, so let's just look at an example, and we'll look at more of these in class. So let's say I have lithium carbonate. Okay, so just like yesterday, I'm going to find the symbol and the charges for these two ions. Lithium is Li with a +1 charge, or just a plus because the 1 is understood. Carbonate is CO3, and it has a 2 negative charge. All right. Now, if you were a crisscross person, or even if you were a balancing, just a outright balancing the charges person, you'll still get the same answer. So let's do balancing the charges. Okay, let's do that one first, and then I'll show you how to do this with the crisscross method. All right, looking at your oxidation numbers, +1, -2. If you put these together in a 1-to-1 ratio, the overall charge will be negative. So what I need to do is add another positive one. So now you can see 1 + 1 is 2. 2 negative, so 2 positive, 2 negative, it'd be neutral. So when I'm writing the formula, I'm telling how many of each. There are 2 lithiums, so that's why it gets a 2. There's only 1 carbonate, and so the whole thing, the CO3, comes down. All right, if I was doing this with the crisscross method, let me just rewrite this quickly. I bring down my symbols. The Li, the CO, and the 3 must come down, okay? And then I'm looking at, this is a 1, so it's an understood 1. It's going to become the subscript for the carbonate, and the 2 becomes the subscript for lithium. All right, and when I do that, it becomes Li2 CO3. So either way, you end up with the same formula. It's just which method you prefer. We're going to work more of these examples in class today.